to get to tricky examples. If you guys have any input further, just come talk. We'll figure it out. All right.
Should we write that down too?
Yes. I think so. I think it might be useful. Once again, it should be on your forever card, so it shouldn't be a huge, huge, huge deal. Wait a minute, pause. Where's the arc cotangent and arc cosine and arc secant? No, cosecant.
It's the negative.
Oh, that's right. So basically, if we just think about the negatives, right? Then we would have the other version as well.
That looks like a C instead of
Like a C instead of 9?
and R for inverse integral. Yeah.
For when you wrote integrals at the very top.
What's that?
Okay. Arc cosine. We should put we derive Miss B crazy.
Sorry, can't hold the that's painfully true. Brendan.
He's tracking with me. He's tracking.
Christy, we would never drive you crazy.
No, we don't drive.
We'll drop you off.
We derive.
We don't even drive her crazy. We like inverse her to happy. That's kind of cute. Integrate her to happy.
Some days that's true. Some days that's true.
I hate
You do add spice.
Wait, actually, can't we just put that on like the bottom? That's what kind of cute.
Spice it up.
Yeah, you read
Oh.
Kyle, I don't think.
Caroline, I think that's your water bottle if you want it. If not,
Wait, why did she do that?
it was over there yesterday and someone thought it was yours.
It is my water. Where did you drink it?
What do you say? Did he say no? We can't talk him into it?
I don't know yet. I have to talk to my friend. Okay.
James Calvin is coming.
James Calvin's calling. James is going.
Maybe Maggie.
I have one of these already. It's the same for all of them.
Oh, that's the, no, wait, the dates, I updated that one.
If it's negative 1 over
So your project
so
definition.
then it's uncotangent.
All right, let's go have some fun. All right, the rest of class is pretty much having fun, and then if we're in the sense of practicing our tricky integrals with the U sub. Some of them you kind of saw last year, but let's see if you remember how to do them. Yeah.
Which one is the absolute value one?
Bottom.
No.
there's
Like there's one
one
where
in
the answer, it would be like arcsine absolute value, not parentheses. I remember we messed that up last year.
Yeah.
For our trig, no, you mean ln. ln is absolute value of U.
No, I swear.
I swear.
I know the class
Come on, get out the forever card. You're the one that brings them to the class period.
Hold on, I'm looking. ln is absolute value of U, but they're saying it's another absolute. Aren't you thinking of this one if there's
it's on number 2, the arcsine talking absolute value. Taking the integral of like a trig.
I have it on my forever cards, but they're in my
Yeah, we
pocket.
goofed it up last year. I remember
In
that.
his binders.
Oh. It's the integration, well, double check me, this is what Kyle reminded me. There is another integral rule with absolute value. It could be what is the integral of tangent. It would be ln, negative ln, absolute value of cosine. Like there's those ones with absolute value.
No, it was number 2.
We had an absolute.
We had an absolute value over on the U over A.
How am I missing this? Okay, I think you should get started on a problem. Let me go open up the forever cards from last year because I should have updated them then. Let me figure out what you guys are talking about. Alright. Does anybody have their forever cards from last year with them?
I'm looking at car bodies. I don't know how to lie. Not that you're not lying.
So it should be the inverse trig integration, which would be pretty fun. Because she uses her resources.
You use part method and then
No.
Wait, I still
The bottom.
Come on, play with it. Ask your groups. Who's you?
part method make the U.
Look at all this group chemistry. Oh my gosh, I love working in group. Don't you, Kyle?
I know, right? I love it.
I love it, Noah.
I know. No, you don't. Give Katrina.
So that's the driving speaker.
Act like group love. No, but Katrina's third of group love. Katrina, you make up for missing two.
I guess you're gonna be disappointed.
Hey guys, who's you?
Oh, it's arc secant. Arc secant is absolute value.
What? No, she's talking about the previous slide.
Yeah.
Okay.
She did not talk about that.
Don't worry, they're not talking about this problem. She's trying to help me out with the formulas.
U is gonna be 2x.
I always miss like the crucial part.
Wait, why can't you just do a function and then split it up and then make it 2x to the
Why
next?
does it say Nathan?
Oh, look! Our bookkeeping has Danny delivered our tic-tac-toe method in the picture.
Why can't you just split it up and
It's not.
Because they don't.
I still can't get them.
The second part then.
What?
I'm able to integrate the second part.
Because it just roll 1 over, then you just make it x is negative 2x, and then you just solve to the negative 1.
I didn't realize.
It'll be x to the negative 1 of the whole thing.
Negative 2, x to the negative 2 plus 2x to the negative 1 plus y to the negative 1.
I think that's because we didn't put the absolute value here. Like with this, you so put it here.
To make it there is no absolute
Yeah.
value, do we need to put it out?
Yeah.
Okay, guys, technically this formula for arcsecant and cosecant is right. Alright guys, hold on. We're getting back to that example as soon as I cover this one. Technically this formula is right, but sometimes you will see the version of 1 over non-absolute value, that's what I was thinking. Non-absolute value of u, square root of u squared minus a squared. And if you see that, you can still go to arcsecant, or similarly there's a negative arc cosecant, as long as you make the u absolute value in the answer. So we can leave the absolute value off of this u, or there might not be an absolute value, and we would just put it into the antiderivative instead. So that's what you guys were thinking. This one, if we do have an absolute value, that is the strict rule, and so we would go straight back to the original. But if there isn't an absolute value, we would just go into the antiderivative. Poor little calculator. Okay, so, Corey, your idea is to do heart method. That's not necessarily bad, except, what would be your u for the 4x over? Yeah, it won't work. Because if we make the denominator u, well, wouldn't that be the first thing that you guys would try, is to make the whole denominator u, right?
No.
No?
Out of 2.
No, I mean like to make your u. You can't factor out a 2 from the denominator. So if the u is x squared, what would be your du?
2x.
Which would be dx equals du over 2x plus 2, right?
Yes.
Now just plug and chug. So you would have over u right here. Some of you might or might not see what to do with that 4x over 4, but hopefully you'll see it in a second.
It cancels.
It cancels after u.
Factor out.
Yeah, factor out a 2, then you have 2x plus 2. Now I can go ahead and say, you see it? This one actually wasn't as tricky as it could have been, because we can pull that 2 out. These will end up reducing, and we just have 1 over u du, which, ooh, who's that?
And then
2 ln of who?
x squared plus 2.
Oh, you have to absolute value it.
We have to absolute value it because the integral of 1 over u du is ln of absolute value of u as long as the argument could be negative, which, depending on the x, I mean technically you are adding, so yeah, for some fractional quantities, if it was a negative fraction, this might overrun that. It's possible. If we complete the square, maybe it's not possible. What would that be? X squared plus 2x plus 4. I guess that wouldn't be. Is that the x plus 1 squared plus 4? Has a vertex at negative 1, positive 4, and it's concave up? Oh. Why did I do this real quick?
See if it needs to.
Yeah, it's a parabola, it's been shifted up here. Well guys, is this ever going to be negative?
Never.
So actually, what can I do with this expression? If it can never be negative, what's the point of the absolute value? There is none.
But is it wrong if you do have it?
Well, I'm just trying to make sure that you don't not choose the right answer because you think you need absolute values. Does that make sense?
But then would that would
have
be
both
both?
answers.
Because isn't the first one would be answered wrong?
Yeah, we blame the square.
would be answers. Oh, wow.
Who knows? They don't usually have two different representations of the exact same correct, but they might do something like put a minus, and if you guys aren't totally solid on your answer, you might choose the one with absolute value over the one that doesn't. It was the squared. Good. Alright guys, that wasn't too bad. Probably almost always the first thing you think of is the entire denominator equal to you.
Yeah.
Now what about this one?
No.
Why not? We just did the entire denominator equal to you, why not do it again?
Because then you'll get stuck with 2x plus 2.
There's no x up top.
So then just do x.
Make it 5.
But how do I do u squared plus 2u plus 5?
U is
Well, if x is u, then
What did you just see me do with this a second ago?
Untie the bottom.
If it's not 1 over u, ln, what else has a 1 over with stuff in the denominator? Arc, trig. Ooh. U squared plus a squared, maybe it's arctangent? But to get a u squared plus a squared, don't I need to complete the square? I just did it. Didn't I? X squared plus 2x plus. Let me remind you real quick of how I complete the square. Yeah, literally, it's how you want to do it. Because there is no du component, there is no x for me to even work with up top.
Isn't it 1 on the bottom and plus 4?
Now, remember we take half of the inside? 1, square it. What we do on the inside, we have to look on the outside. It's still just plus 1. Offset it. So that way we're just adding 0 creatively. Then I end up with x plus 1 quantity squared plus 4. Why does that make all the difference? Who's you?
Plus 1.
Good. Because u squared plus a squared, right? So u equals x plus 1. A equals 2. Du, oh that's easy, just dx, right?
yeah. See.
So what would say?
Isn't it 1 over a?
Yeah, Corey's going to the answer. 1 over a, which would be 1 over 2, arctan, or tan inverse, of
X plus 1 over 2.
U over a.
got it? What was different between the two? The one before had an x. And actually, he was really nice. He had an x and a plus. And you could factor out a 2. Anyway, he was really nice in the last one. This one doesn't even have an x. If he had an x, I could do it. You could do it. Halfway. But a little power to it. Okay. Difference between ln and arctan? How about this one? Oh, same thing. That's lame. Yeah. No, go ahead.
Like, you know how like ln is 1 over x?
Yeah.
If we made u the denominator, I know the answer was wrong.
Wait, ready, set, new example on Lucy to Lucy's question, go.
If we did that with the denominator, u is ln of 1 over u. And when that's with ln, and then the whole x squared.
On the last example?
Yeah, to the left.
Well, if you did do 1 over u, the problem is you would have du over 2x plus 2, and you couldn't cancel it with anything. So that's how we get stuck. We still have the 1 over u du, but then we still have x's, so we can't integrate it.
Katrina remembers this misty.
Nice job, Katrina. I'm just gonna form it.
Yeah, Pascal's triangle, where does it go?
Well, you just do 2 to the 7 because then you do. Just give you 120.
Oh, yeah, you can do that.
128x and then
2 to the 7th, and then negative 1 to the 0, then 2 to the 6th, and negative 1 to the 1, and 2 to the 5th.
There's just one thing to do.
That just sounds easy.
This hurts.
I don't know Pascal's triangle.
What are you guys doing?
I don't know. Oh no, I just.
You do u sub and then you solve for x with the u and then you look at you.
Got some crazy you said.
Hey.
Oh.
Integration of crack.
Yes, integration of
What?
crack. Because nothing's better than drugs. Wait, yeah.
Yeah,
That should be on our sweatshirt.
Wait, can that be your switch?
That
Oh, no.
No.
I was thinking of integration of crackers.
False.
Crystal math.
Crystal meth.
That's a good idea.
That one will pass for sure.
Yeah, I think so.
I mean, a pop song got past them, so I think they'll be okay.
How many are the people passing it to?
They referenced a Jay-Z song,
Yeah.
and it was Mrs. Leon's class too.
Wasn't it
She
Jay-Z
didn't know,
song?
and then they got in trouble.
It was Ariana Grande.
She didn't know.
As if that's-
And they
Wait, she got in trouble?
Okay,
Wow.
it's like still, it's fine.
99 problems?
Well, the class got it.
99 problems? That's
Wait, so
not
they,
Ariana
so they
Grande
just thought
song?
they were just being original, that's it. Did she just think like, wow, these kids are so creative? Well, she didn't.
Did you know she actually looked up the song? She didn't know what it was. She couldn't listen to 6 seconds without having.
Well, she didn't even know it was a song. She just thought that like, oh, they like this. All right, cool. But now all of us know it. Double check it.
Italian crystal meth.
All right, what have you guys got when you plugged in?
Pascal's trying.
Wait, pause. What was the point? Why did we even do all this stuff? Like, why not just keep the x there and then plug in the u to the 7th and then go ahead and plug in du over 2? What's the big deal?
Now you got an X.
Now you have an X there.
I can't integrate.
And make it
right?
B.
So that's why.
You have to find X.
That's why I have to go ahead and plug and chug. But now that I plug and chug, I can go ahead where I couldn't. Pause. Most of you would not have made this algebraic mistake, but my entire all my pre-calc classes, except for honors, half of them would have gotten it. You can't bring it in, right? PEMDAS says 7 first, then x. You can't go bring it in at times x. But now, can we bring in the u to the 7? Yes. Yes. So therefore we have 1/4, the integral of u to the 8th plus u to the 7th. How do we integrate, cool kids?
I can't.
They're not like terms. But what I can do is go ahead and integrate them separately and get u to the 9th over 9. Now, hold on. The AP guys love to trick you on simplifying this one. Let's not even put in the u yet. Let's just ask, how would you simplify this expression? Don't distribute. They're going to factor out.
Okay.
They're going to factor out.
Oh, like the denominator.
Yeah, they're going to pull out the u to the 8th, first of all. But then they're also going to say, oh, hey, but wait a minute. We should get a common denominator and then pull out the common denominator. And the reason actually is quite nice. It really does make everything look a little bit better. Because you could make this 8u to the 9th over 72 plus 9u to the 8th all over 72. And it really does look better when you pull out the 1 over 72. Which would end up being, what, 288? U to the 8th, and you would end up with 8u plus 9. Now, we haven't plugged everything back in yet, but some of you, when I start plugging crazy stuff in, or not crazy stuff, but what u equals, it gets a little messier. Just think about it. The AP will always get a common denominator, pull out that fraction, because they're like, oh, look, it's pretty. And they're right, it is. It is a lot nicer. Who was u equal to in the beginning?
2x plus 1.
Good. So I can go ahead and plug in. You guys know, now that everything is so much simpler inside, of course they're going to go ahead and simplify that also. And make it 16x minus 9 plus, no sorry, minus 8 plus 9 would be plus 1. I double check my math. Does anybody else get their independent like me?
Yeah.
So this was not just the crazy integration, the crazy substitution, but it was also how to simplify. 2 different things that we encountered in that problem. Does that make sense? Okay. What's some other crazy U sub stuff that we might encounter? Let me give you guys a couple more seconds. Some of you are still writing. For sake of time, let's go straight to the last example. I'll dual page it for those of you guys that are still kind of working. Can you guys read it?
Yes.
Yes, ma'am.
Is this a straight complete the square?
No.
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 Because I have an x up top, and I have a plus. Is this a straight u sum?
Yes.
So we have to think about the u sum. Who would be u?
X squared plus 3x plus 7.
Who's du?
2x plus 3.
Do you see the problem?
You can't solve for x either.
So for X.
Could you technically make the top to you? I want to use one right
So for X.
Can't multiply.
Pause. What's it gonna do?
Pulled out a 2.
Why? Okay,
Almost.
5, 3.
so what happens when I plug in?
You get 1/2 of this
Can I pull out the 1/2?
Yeah.
What can I do?
Oh, no.
Do I have this up here somewhere?
Yeah.
I have 3 halves. I just have too much. How much too much? Can't I split up 5 to be 1.5 plus 3.5? Is that 7 halves? Then,
Oh, you do it like that.
now hold on.
Could you heart method it?
Well, 7 halves over here.
You got a heart.
Yeah, it's a hard menu. What would be over here?
Wait, I didn't do the u sub. Wait, I don't have the 1/2. I don't. Wait. I split the 5 up to keep the 3 halves with all the u sub I was doing. So I went back to the beginning. I split 5 up. I moved the 7 halves over. He doesn't have an x anymore.
Oh, so you can pull them out.
So who's this going to be? 1 over u? No, there's no du. This is going to be arctan. There's no x. There's no x. So I need u squared plus a squared to be able to do it. I can't I can't do u and then du. I have no x's up top. This one I had an x, so I am going to be able to get rid of that du. So I'm going to have 1/2, 1 over u du. But over here,
Plus 7 halves in
I can pull out the 7 halves, but I'm going to have 1 over. The only way to make this work is u squared plus a squared. So I'm going to have to do
Plus 2 minus 2.
3 cut in half is 3 halves. Squared is 9/4. Plus 7 minus 9/4. That's right. I had no x, so I couldn't possibly get a du into this. So I can't. Well, I'm trying to complete the square, because if I can complete the square, x plus 3 halves squared, and I'm going to have 28/4 minus 9/4 is 19/4? Double check my mental math, guys.
Now it's
Yeah, you're.
This is not real.
This is not that. What do you call it? B? This is B.
I would have got this one.
Which is why I'm showing you. You're welcome. 1/2 ln of. Who's you? 2x plus 3? Is that? No.
No, isn't it x squared? X squared plus 3. Yeah.
Oh, I see. Thanks. You guys can. Oh wait, complete the square. Is this gonna be negative ever?
No.
It's still concave up, so we can actually make that in. Oh, we'll do that later. Plus 7 halves. You can make this v. V equals x plus 3 halves. But guys, how's dv? Oh, he's good. He's just dx. And then who's a? Square root of 19 over 2. Yay! Cozy. So plug it in. 1 over a, which would be 2 over root 19. Nice looking answer. Arctan of u over A plus C. That's roughly right.
That's an exciting part.
That's one right representation. You can just put those in and then do it.
It's your name.
Cool, I could make it a square root. Go team.
Jim, Lauren. I know.
Alfie is probably supposed to be working. I mean, that's fun and all, but.
I'm gonna get it right, and then I'll put it on the board for everyone.
2x plus 3 all over root 19.
Yeah.
Exciting. Gotta keep you guys on your toes. Bye. I'll scare people with your problem.